Hello Math 3 students. So today we are going to cover adding and subtracting rational expressions. So this isn't in the big packet. I do have these notes posted on Canvas. So what I want you to think of when you're doing these is we did talk about how you add fractions, right? And we know that when you add fractions, I should say add or subtract, we know that we need a common denominator. Right? So keep that in mind as we go through these problems. So if we look at example 1, we're trying to add these fractions here. Now, fortunately, we've already got a common denominator here, 3. Both of these fractions have a 3 in the denominator. So we know from adding fractions normally that the denominator is going to stay the same. Then we just have to add these on top. We have to add x minus 4 plus 5x. And that's going to give us 6x minus 4. So all you're doing once you have a common denominator is combining like terms on the top. So now let's go ahead and try the next example. So this is an example of subtraction. So again, we have to look, do we have a common denominator? So here we do. We have x plus 5 and x plus 5. So that's great. So we know that our answer is going to have x plus 5 in the denominator. Now, one really tricky thing about subtraction, and I guarantee you so many of you guys are going to make this mistake. You have to make sure that when you're doing subtraction, you distribute this negative sign to all of the terms on the top. So I'm going to show you what I mean by that. So first off, on the top of this fraction, we've got 2x plus 3, right? Now we've got minus x minus 3, right? Because we're subtracting the stuff on this second fraction here. You have to make sure that you distribute this. So you end up with 2x plus 3 minus x plus 3. You have to distribute this negative sign to both terms. That's super important. Then that's going to be all over our denominator, which is x plus 5. And now all we have to do is combine like terms. So we get x plus 6 all over x plus 5 as our answer there. So just to kind of look back at what we did here, we already had a common denominator to begin with. So we went ahead and we distributed this negative sign to each of the terms in our second fraction there, which turned this positive x into a negative x and turned this negative 3 into a positive 3. Then we just combined like terms and got our answer. All right, so now here's where things get crazy. So if you look here, we actually don't have a common denominator. All right, we've got x squared plus 3x plus 2 and x squared minus 4. Holy smokes. All right, so what you want to do here is you want to factor the denominators. This is so important. So when you're adding and subtracting, you need to factor the denominators. So we're going to get a lot of practice with factoring here. So we've got x minus 4 on top, and then if we factor the bottom, we have to figure out what multiplies to give us 2 and adds to give us 3. So that's going to be x plus 1, x plus 2. All right. Now for this next one, we have to factor this as well. We're going to keep our x plus 3 on the top. And then we have to see, okay, well, how can we factor this? Now, this is a difference of squares. All right, so if you remember difference of squares, we can use that a squared minus b squared is equal to a plus b times a minus b. All right, so factoring x squared minus 4, we're going to get I'll do x plus 2 and x minus 2. So what you do is you take the square root of both of these, and then you follow this pattern up here. All right, cool. So now what we need to do is we have to work on getting a common denominator. So you have to make sure you factor, and then you work on getting that common denominator. So what you have to do is you have to say, okay, well, let's look at this first fraction here. This first fraction has an x plus 1 and an x plus 2. All right. Now notice how this fraction has an x plus 2 and this fraction has an x plus 2. So that's great. We're good on the x plus 2's. However, this first fraction is missing an x minus 2. Do you see how this guy has an x minus 2? So what we're going to do is we are going to multiply this first fraction by x minus 2 over x minus 2. All right, so we've got x minus 4 all over x plus 1 times x plus 2. And then we're going to multiply this by x minus 2 over x minus 2. All right. Why did I do this? Well, what I'm trying to do is I'm trying to get both of these fractions to have the exact same denominator. So when I do this, I get x minus 4 times x minus 2 on top. And then I get x plus 1, x plus 2, and x minus 2 on the bottom. All right. So we're getting there. Now this guy's got 3 people on the bottom there. Or I guess 3 binomials would be a nice thing to say. So now we're going to look at the second fraction here. This guy is missing the x plus 1, right? Which this guy already has an x plus 1. We need to get the second guy to get an x plus 1. So we're going to do x plus 3 times x plus 1 over x plus 1. Now, why am I doing x plus 1 over x plus 1? That's the same thing as multiplying by 1, right? When you have the same thing over the same thing, that's the same thing as multiplying by 1. So that gives you equivalent expressions. I should say equivalent fractions. All right, so we multiply these, and we get x plus 3 times x plus 1 all over x plus 2, x minus 2, x plus 1. So that's a lot of work. But now, look, both of these fractions have an x plus 1 in the denominator. They each have an x plus 2. And then they each have an x minus 2. So now we've got a common denominator, which is great. So the next thing we're going to do is we're going to rewrite this, and we are going to FOIL the top parts here, okay? So you're going to FOIL or multiply the numerators. All right. So if we FOIL this guy out, we get x squared minus 2x minus 4x plus 8. All right, which is going to give us, we're kind of running out of space here, which is unfortunate, which is going to give us x squared minus 6x plus 8 all over our common denominator, which is x plus 1, x plus 2, x minus 2. All right, so we're making progress, guys. Now we've got this other guy. Let's go ahead and FOIL him out. So we get x squared. Use blue next. Plus x plus 3x plus 3. So now we've got x squared plus 4x plus 3 all over our common denominator of x plus 1, x plus 2, and x minus 2. All right, so now let's go ahead and actually add these now. Now we've got common denominators, and we've got our numerators FOILed out. So now it's actually pretty simple. Now that we've done all the hard work here. We've got x squared minus 6x plus 8 on the top, and then we've got our denominator. And then we're going to add that to our other fraction, which is x squared plus 4x plus 3, all over x plus 2, x minus 2, x plus 1. All right. So now all we got to do is combine like terms on the top. So these guys can get added together. So we get x squared. These guys can get added together. So we get minus 2x. And then these guys can get added. Ooh, whoa, whoa, whoa. What happened there? And then these guys can get added to, ooh, you can't even see that. Get added together, which will give you, I'm not even an orange anymore, which is going to give you 11. And then, of course, you keep your common denominator, which is x plus 2, x minus 2, x plus 1. And then this would be your final answer there. Holy smokes, that was a lot of work, right? So definitely tricky. All right. So, and guys, feel free. I know clearly I'm kind of running out of space here. So feel free to use a separate sheet of paper if you do run out of space. All right. Let's go ahead and try another one. Another tough, but you guys can do it. So, again, we're not starting with a common denominator here. So we need to get a common denominator. And how did we do that up here? We have to factor it. So factor the denominators. So this first guy is actually already factored. So he's all good. We got x plus 2 all over x minus 6. But now we got to go ahead. We'll leave this guy on top all good here. So we got x plus 5x plus 14. But we got to factor this bottom. So I want you guys to try and factor this bottom. We have to figure out what multiplies to give you negative 24 and adds to give you negative 2. So if you factor this, you should end up with x minus 6, x plus 4. All right, which is pretty good because this guy already has an x minus 6. So we're pretty darn close to having a common denominator. It's just that this second fraction has an x plus 4, and we need to get an x plus 4 here. So we're going to multiply by x plus 4 and x plus 4. So we've got x plus 2 all over x minus 6, and we're going to multiply by x plus 4 all over x plus 4. So this way we can get this first fraction to have the exact same denominator as our second fraction. So when we do that, we get x plus 2 times x plus 4 all over x minus 6 times x plus 4. And now we can go ahead. We want to FOIL the numerator. All right, so when we do that, we get x squared plus 6x plus 8 all over x minus 6, x plus 4. All right, so now this fraction here is equivalent to this fraction. When you do this thing where you multiply by something over itself, you get equivalent fractions. It's the same, you know, as if you had, like, let's say 1/3 and you did times 2, which would give you 2/6, right? That's the same, that's equivalent to 1/3. So that's essentially what we're doing when we multiply the numerator and denominator by the same thing. So now we're gonna go ahead and add these together. So we got tons of space here. So we're going to go ahead and replace our first fraction by our new fraction here. Hold on. Plus 6. Where did I lost my 8 somehow. All right. So we've got x squared plus 6x plus 8 all over our denominator, which is x minus 6, x plus 4. And then we are going to add that to our, we're subtracting here. We're going to subtract our second fraction, which is x squared plus 5x plus 14 all over x minus 6, x plus 4. All right, so now, what was my big thing I said about the subtraction here, right? You have to distribute that subtraction sign. That is so important, okay? So we're going to go ahead. We can distribute the subtraction sign to each term. So we end up with x squared plus 6x plus 8 minus x squared minus 5x minus 14. And then we've got this all over x minus 6, x plus 4. So now all we got to do is combine like terms. These guys cancel. We get x on top, and we get a negative 6. X minus 6, x plus 4. And you'll actually see here, you could simplify this even further and end up with just 1 over x plus 4. That won't always happen, but sometimes it might. All right, so we've got one more problem here. So again, we're trying to subtract here. However, we don't have a common denominator. The number 7 is the same as like 7 over 1, right? So I want you to think about, if you have 7 over 1, what could I multiply this by so that the denominator is x minus 9? So think about what I could multiply top and bottom by so that my denominator is x minus 9. So all I need to do there is I'm going to multiply my numerator and denominator by x minus 9. All right, so we get 7 times x minus 9 all over x minus 9. And we can go ahead and distribute this. And you end up with 7x minus 63 all over x minus 9. So now we can go ahead and replace this with this. So we get 7x minus 63 all over x minus 9 minus 4 over x minus 9. So now all we got to do is kind of combine like terms on the top there. So if we get negative 63 minus 4 is going to give us a negative 67. So we get 7x minus 67 all over x minus 9.